Today we're going to be rebuilding our intermediate shaft. This one we have already measured the gear backlash and it is outside of tolerance. We're also going to be cleaning the shaft and putting new timing chain gears onto the shaft. So the first thing I'm going to do is start pulling our circlips off. This one here, we want to pull this plug out for two reasons. One, these plugs tend to loosen up and create an oil pressure relief problem where oil leaks out around them and into our front intermediate area, and that can contribute to leaks, but we also want to clean this passageway. So we're going to, with our circlip pliers, remove that one, and then this is just an M6 bolt is going to pull this plug out. So I've just screwed that in. I'm just going to carefully work that plug out. And these are usually pretty disgusting in here. It catches a lot of debris. That's why we've got to clean them out. Then next I'm going to pull my circlips for my timing gears next. And then the last one, this is our circlip for our oil pump drive, and we're just going to pull this off, even though right now it's not holding anything, just so that we can clean everything. Okay, so there's all our circlips. So the next thing, to remove these timing gears, these are a press fit, so I'm going to use a two-legged puller in here and pull this gear off. First gear. Second gear, and we've got some pins right here, some Woodruff keys. What I'm going to do is fold all of my lock tabs down and undo our 6 bolts to remove the intermediate shaft gear. Here is our disassembled intermediate shaft. We're ready to get this into the parts washer, which I'll have to turn on and heat up. And we are ready to clean everything up, measure our bearings. I've done an initial measure. Right now they are within spec, but I want to have a better look at them once everything is cleaned up. And we also want to clean down inside here. As I said, this tends to house a lot of really nasty, gunky, disgusting stuff. Alright, so I have washed our shaft now and scrubbed all down on the inside here with my brush, had good flows coming through. So before we start putting this shaft back together, there's a few things that we need to do. One thing I want to do is I want to make sure that my intermediate shaft flange, because this flange is an interference fit with the new gear, that it is concentric, because there'd be no point putting it all together if it has a slight bow in it, because then that is going to create issues running with my crank. Now what I'm looking for here is 0.01, 0.015 or less would be optimum. And what I've done is I've put in the bearings into my intermediate shaft case. This is acting like a set of V-blocks. This is the best place to measure because this is where the shaft is going to run. Now, all I want to do is I've set it up with my dial gauge, and I'm just going to rotate that around nice and easy. We want to go nice and slow with this so we can catch all of our movement. We're coming back around to 360 degrees. And we're right there. So we had about 0.005 up, 0.005 down for a 0.01 on that tolerance, which is pretty good. It's about where I want to see it. Now, a couple of other things that we're going to do next is I'm just going to measure these shaft bearings, make sure the journals are within spec. But I can safely say that my shaft is still nice and straight. It also rotates nice and smoothly. That's another thing that I'm looking for when it's sitting here in the case. I want a nice smooth rotation. And we also want to look at our end float, which is the shaft moving back and forth. And we'll go ahead and measure that next. So to measure our end float on our intermediate shaft, I've got my dial gauge zeroed. I push the shaft forward. All I want to do is push the shaft back and measure the amount of movement. And what we're looking for with a new bearing is 0.04. You'll see that I can kind of flex it past there if I really pull hard. But we're looking for that jolt. Right now, measuring, we're on 0. We're coming right at 0.04, so that's right on the minimum specification for our end float. So that means our bearing inside our case is correct, and also the distance between these 2 points is also within tolerance. So recently we had a question from one of our subscribers about the thrust bearings on the intermediate shaft, and his problem was when he laid the intermediate shaft into the case, he had no end float. And right now I will put the dial gauge on because it's hard to see, the end float's so small anyway, but I can feel that this one right now has 0 end float. And I want to show you a quick way. And this is something that I was taught a very, very long time ago by a very old mechanic about seating thrust faces and what you can and can't do. So let me put a dial gauge on it and we'll measure what we got and then we'll fix it. All right, so I've just spun my case so we can see the dial gauge a little better. And right now, if I try and move this shaft, I have 0 movement. And this is quite common. And all it is we need to seat our thrust bearings right here. So I'm just going to pull my dial gauge out of the way. And to do that, I'm just going to use a ball peen. And this is totally okay. We're not looking to really beat this to a pulp. But what I want to do is just seat the bearings both directions. So right now, my shaft already is rotating really, really nicely. And all this is doing, it's forming the actual thrust bearing. So this part here where it bends down around, this, when it's formed at the factory, often is not 100%. And it's because every case is slightly different how this is machined. So I'll do the same with main bearings as well. I'll set a main bearing in and I'll set my other bearings in on the crank, and then when I lay my crank, I'll give it a couple of taps on the end float to seat that thrust bearing up against this surface. So let's just lay our shaft back in right now. It already feels, before I couldn't easily spin it with my fingers because I had no clearance. We can hear the end float, and so I'm just going to bring my dial gauge back in. And it looks like we need to go a little bit harder, but right now, 0. We're almost at that 0.4. And the other thing I just want to make sure is that my bearing is seated all the way down. Feels much nicer right now. Okay, right now we're at 0.03. Just going to give it a little more of a tap. Looks like we're right at 0.045. So that's it, back into our tolerance range. Now this bearing is seated to this side of the case, so I'm going to leave those in place. We've already done the same to the other case. In a worst case, if you seat it and you still can't get the numbers, you can take your bearing scraper and lightly scrape a little bit of the babbitt off. You've just got to be careful doing that, because if you scrape too much off, there's no going back. It means buying another bearing. The good thing is these bearings in these locations are not particularly expensive. But that's how you would correct an end float situation if it was too tight out of the box. The last things I want to check is my bearing journals here. Now I've just given these a light clean with Scotch-Brite just to give them a buff. There's no heavy scoring or any signs of major damage already. We already know the shaft is straight. We've measured right here, which is where our gear is going to run. We already know our thrust surface here is good, so the last thing I want to do is just confirm that my journal sizes here are still good. So the size on, we're going to start with the little end here, is 23.980 through 23.967. So the way that I like to measure these, because it's very hard to take a measurement on a round surface and get it accurate, so I set my micrometer and use it like a feeler gauge where I pass the shaft through the jaws. And right there, that sails right through, a little bit too easy. I got a little bit of wiggle in there. So I already know that 23.980 is a little on the big side. So it's going to go down to 23.970. And what I'm doing is I'm just finding that sweet spot, and I can kind of zoom in if I want to make sure it's 100% accurate. Here I'm just carrying, really, is it in tolerance? So at 23.970, okay, the shaft is already, I could wind it through, but it's already tight there. So that means my shaft measurement is somewhere between 23.980, 23.970. So just for interest's sakes, let's open it up, split the difference, go to 0.05. And that is a really nice feel. It's got a nice even load on it. So if I had to say it, this bearing from a brand new, being 23.980, measuring 23.975, well within the tolerance, and most likely that's how it left the factory. Just going to check the back one as well, make sure it's in the same shape. And same thing, I got a nice feel going through, where it's just got to get into that sweet spot before it sails through. So this bearing is fine. Next bearing that we're going to set is at 24. 25 is the specification from the factory, down to 24.980. Okay, so we're at 25.001. Same thing, kind of on the loose side. Better, but still a little on the loose side. So let's go to 24.980. All right, instantly difference there. I got to get it perfectly aligned, and it feels good as it comes through. So right there is my centers. I got good pressure. So right on the minimum, still within spec, so completely okay to use the shaft. Okay, so now we know our shaft is rebuildable in that the basis of its support is all good. We're going to look at our gears and why we are replacing them. So when it comes to replacing a gear, here's my two old ones that came off the shaft, and here is my new ones. So the areas where we want to look at is on the side here. This is the thrust surface, and we can see where the chain has been wearing in on this gear. And it's got a fairly substantial, if I take my punch, I can actually get stuck on that lip. It's got a fairly substantial side load. That means the chain was running against the side of the gear. Also means that at some point in its life that the chain depths were not set correctly, and this had more load on here than it should have done. If we look on the other side, we can see there's still a little bit of an imprint from the chain, but not as big as this side. So that means the chain wasn't running straight and parallel to this gear. The other thing that we look at is here, and how much of a U-shape we have in there. You can take a new gear and put it back to back. Line up the points and look through, and what you'll see, if there is wear in this U shape, you'll actually see it, and I'm going to hold it offset so you could see what it would look like. When you look through and you see the new gear, you'll see there's a little section right there. Now this gear isn't that worn in a U shape. It could be possibly reused. We're going to replace them mainly for this side wear on the chain, and these are not horribly expensive, so it's always good with the amount of miles that this engine had on it to put in new drive gears, as this is controlling our valve timing. But same with the other gear, we can take a look at its general condition. It's had some little bit of damage around the side here, not as bad as this gear. So this chain was a little more parallel on both sides. Same thing though, we're just going to replace them due to the amount of miles on the engine. Okay, so when it comes to installing our new intermediate gear, these are an interference fit with this flange right here, and we've already checked our flange to make sure that it is concentric. Now when I put the gear on, you'll notice that it doesn't want to actually sit on. That's due to the fact that it is an interference fit. So to make it a little bit easier to install, what I'm going to do is I'm going to take just 3 long studs that I have, and I'm just going to screw these in to my intermediate shaft, and this is going to act as a guide, so when I go to put my gear on, I'm not going to have to worry about trying to line up the bolt holes. So we got those 3 shafts right there. That way I can slide this on and I'm lined up with all my bolt holes. So when I'm going to install this, I'm going to use my hot air gun. I'm going to heat up my gear, and I don't want to just hammer it on because I don't want to run the risk of not being concentric. On the back of this gear is a machine surface right here, and it's quite simple. Heat it up, line up my studs, drop it on. May take a little tap, but at least that'll expand the gear out and make it a little bit easy to install. Also, you've got the 0 marking here. This designates the size, not a timing mark. Doesn't matter where that goes on the shaft. You can put it wherever you want, wherever you feel like on the day. Okay, so let's heat it up and put our gear on. Okay, we got our shaft heated, and we are straight down and on. Just want to make sure, I haven't put my lock tabs in yet. Just want to make sure though that my other bolts will screw in. Perfect. I'm going to let that cool down, and then we'll put our lock tabs in and torque our bolts down. These are torqued to 25 Newton meters, that's 18 foot-pounds. Alright, now it's cooled down. I'm going to take my guide studs out. Take out our bolts, and I'm just going to put my lock tabs in. Alright, so before I tighten the bolts, I want to fold down the inside of the lock tab, just because as I tighten it, it's going to move, and I want to make sure that I have one side secured up against the gear. Okay, so now I got my lock tabs in. I'm going to go put this in my soft jaw vise and torque all of my bolts. Okay, there's all of our lock tabs installed and bent up where they need to be. I've got my gear on. Generally I don't want to put this side on until I've checked this gear in the crease with the crank, but our crank's sitting here and it isn't ready to drop in yet. I need to pull these gears, clean everything. We're going to do a polish on the crank. So what I'm going to do is I'm just going to install this gear onto this side. These are going to install the reverse of how they came off. We're going to put this flanged raised section facing the flange right here, and circlip's going to go right here. Again, because this is an interference fit and we do have a keyway, I'm going to heat this gear and put it on. That way it should slide on. This way I don't be very hard to line up the Woodruff key. I mean, we could do it, but I prefer to just heat it and then put it on. So I was able to put the sprocket on, but it cooled a little too fast. I didn't really have it as hot as it should have been. But I'm lined up. If we look right down underneath, we can see the keyway's nicely lined up. So I'm just going to use my press now to just press it the rest of the way on. Alright, so now I've pressed the sprocket all the way on. I can check my circlip fit, which is nice right there. Okay, circlip's on, so we're going to check this with the crank. So I'm going to leave this other gear off for right now here. But it's the same process in putting the gear on this side. One thing I can do is I can install our plug right here. Now when I pulled this apart, we could see that the plug was very, very loose. And even now, I mean, it's there, but I don't want to push it all the way in. There it is, and it fell in. Now this being that loose, what I normally do is I use some Loctite 574, and that is the only thing that you can use here. Only because any excess Loctite sealant that goes down inside the shaft will dissolve in the oil and won't become a blockage. This is pressure fed, so we have two holes here. We've already flowed this through with our cleaner. We hit it with our brush, scrubbed it all out when it was in the parts washer, so we know everything's 100% clean in there. All I need to do is reset the plug. So let me grab some sealant and we'll put this together. So I put a very small amount inside the board just as I push it in because I want it to grab 100%. And I'm just going to slide that in like that. Take my bolt out. And I'm going to put my circlip in. Make sure it's in the groove all the way. like this. And then just want to grab my plug, pull it back up against that circlip. That's it. We're going to leave that to set up. So all we've got left to do is put the one sprocket on, but I want to check the clearance of this gear against the crank first. Okay, so I've got my crank sitting in the case again. I'm just sitting on two bearings because all I want to do is check the fit on my intermediate shaft before I put my last drive sprocket on. So a quick thing to do is first I want to make sure that everything goes all the way around, complete 360 on our intermediate shaft. So that means 720 on our crankshaft. Everything feels good. Now, a quick trick for checking if you have not enough clearance between the gears, if I rotate them in reverse direction, if this is too tight, what you'll get is the intermediate shaft will tend to climb out, and that's an indication that you've got a tight spot somewhere. So same thing, I'm going to run that around and give it a complete 720 on the crank. And I'm also feeling to make sure everything is nice and smooth. I shouldn't feel any tight spots anywhere throughout the rotation. And so far everything feels really, really good. Then just a quick grab. I want this to be pretty firm. I can feel a very slight amount of movement. It's going to be very hard to measure, which is good. That's what we want. We want a nice, good, tight fit, but without it being too tight that's going to cause excessive wear. All right, so we've got a range of movement that we can allow on backlash with this. The very tightest it can possibly be is 0.016 of a millimeter. Each one of the graduations on my dial gauge is 0.01. Usually I'm looking for right around 0.02. And it looks like we're right there when I rock that back and forth. Got to be careful I don't hit it too hard because then the whole crank moves. So it looks like we're right on that 0.02, which is usually about where I like them with a new gear, freshly cleaned on the crank. This is going to run in very, very quickly. You can run a little bit tighter too, especially as long as though you check with the rollback and the shaft doesn't try, this shaft doesn't try to climb up and out. If you get any climbing at all out of this shaft, then it is too tight and you're going to have to start playing with different crank gears. But so far everything looks good. We can go ahead, assemble our last chain drive gear onto our intermediate shaft, and then this is complete and ready for assembly. Come on. No, gonna have to press it. Okay, all I got to do is put my circlip on. Nice. All I need to do for the last thing is put the circlip. This is the oil pump drive. So there's a shaft that slides over and there's a circlip that runs right here. The circlip that came off of it is pretty well opened up, a little distorted, so I'm just going to put a new one on it. But that's all we got left to do, and there's a rebuilt intermediate shaft ready to go back into service.